In this session, we will continue where we had stopped in the previous session. So we are discussing about surface heat treatment processes. So where we got two types. One is case hardening, second one is surface hardening. In the previous session, we had discussed about case hardening and different types of case hardening. Today we will move to the next type of surface heat treatment process, that is surface hardening. In surface hardening, we got two types. We will discuss that is induction hardening and flame hardening. Next, we will discuss one more topic that is called as age hardening. So, what is age hardening? So, how hardening is increased or why it is called as age hardening. So, what is the process of age hardening? That is the next topic. So, these are the topics related with the heat treatment. So, next topic we will discuss about ferrous metals. So, classification of metals. So, there we will be discussing about ferrous metals. So, in case of ferrous metals, we will discuss two types, that is cast iron and steel. So, under cast iron, we will be discussing different types of cast iron. Then under steel, we will discuss different type of steel. Under each category, we will discuss its composition, structure and applications. So, under each category, we will discuss its composition, structure and its applications, where we use that particular type of cast iron or steel. So, these are the things we will be discussing in this particular session. So, starting with surface hardening. So, as I told in the previous session, so surface heat treatment is one where the entire specimen is not subjected to treatment, only the surface or the surface up to certain depth hardening is done. So, in that the first case what we discussed was case hardening. So, case hardening is one where the heat treatment process was carried out based on the chemical reaction. So, either adding carbon or nitrogen or both carbon and nitrogen. So, that is one type. So, coming to the surface heat treatment. So, surface heat treatment is once again a type of surface hardening process where the method of increasing the hardness is heating and sudden quenching is done. When the material is heated and sudden quenching. So, quenching is nothing but cooling process. So, for cooling process or cooling process is also called as quenching. So, heating to a certain temperature, suddenly when it is cooled, so its hardness increases. So, this based on this principle, so this surface hardening is done. Now, here no chemical reaction takes place, only heating and sudden cooling. Now, based on what is the medium we are using, what is the medium that is used for heat treatment. So, this is classified into two types. What is the medium of heating? So, if you want to heat the specimen, so we should have a medium. So, based on that, we got two types, that is the first one is induction hardening and second one is flame hardening. So, here how heating is done or what is the source of heating. So, that is what the change in this two types of surface hardening process. So, we will discuss each individual, how hardening is done in case of surface, that is your induction hardening and flame hardening. So, starting with the first one, flame hardening. Name itself as flame. So, a gas flame is used. So, already you know about that is in case of joining process, we got welding, soldering, brazing. Similarly, in welding we have got gas welding. So, where we use a gas combination, oxygen acetylene, oxygen hydrogen. So, when this gas flame is ignited, we get a flame. So, same flame is used heating in this case of flame hardening. That is why the name given is flame hardening. So, we use a flame. So, that is a gas flame generated by a gas, any gas combination, what is used in case of normal gas welding process. The same thing is used here. so for heating the given specimen. So that's why the name is given as flame hardening. How the process is carried out? You can observe the sketch here. So flame hardening. So in case of flame hardening, this is the workpiece. So this is the workpiece. So this is the tube-like structure where water is fed onto the workpiece, and this is the flame holding. So flame holder, what we can call is a flame holder. So this is the workpiece. So this is the quenching medium. So once it is heated, sudden cooling has to be done. So here water is used for cooling purpose. So or water is used as a medium, so for cooling. So that is called as quenching water. Quenching is nothing but cooling water. So here very simple process, very simple process. So this is the workpiece. So workpiece is placed on a vise or any other work holding device. So you should place the given workpiece on a vise or any other working work holding device. Now starting from this end, so this is the direction of travel. So you are moving from this direction, so it starts from this end. So here a flame is generated. So using that flame, we start heating the workpiece from this end. So this is called the direction of travel. So both the water tube and the flame holder will be traveling in the same direction. So both the water tube and flame holder through which the gas flame is generated, it will be traveling in the same direction. So the workpiece is fixed on the vise. Workpiece is fixed on the vise. So then heating is started from this end. So this is the hardened surface. You can see this portion, hardened surface. So this is the heated surface. Still hardness is not completely induced in this region. So this is the region that is not still hardened. So three regions. This is the region already hardened. This is the region where heated surface. So cooling is not done. You can observe here. So the quenching water is still in this at this particular point. So then this portion still heating is not done. So three regions you can observe. So we start gas flame is generated. So heating is started from this end. So the temperature around 500 to 600 degrees centigrade, that is the temperature that is maintained. That is, we apply the flame at this point, we hold that flame at that particular point until the required temperature is generated. So then, so we should have a mechanism, we can have a mechanism where, so gradually it will moving from this end to the other end. Similarly, the quenching water medium, we can have a mechanism, so it should move behind the flame holder. So we can have a simple mechanism. So once it is heated here, once the temperature is reached, that is around 500 degrees centigrade, so the holder is moved from this direction, so it slowly moves. So until, so once it moves a certain distance, immediately quenching is done. So very important, heating, sudden quenching. So immediate quenching is nothing but sudden quenching. So when it is heated, so the temperature will be high, so it will reach the austenate stage. So austinating temperature is the temperature above which it will be, material will be stable. So below that it becomes unstable, so where it changes to other forms. So what it has been discussed in iron carbon diagram. So below the austinating temperature, so iron gets transferred into other forms. So that is what the austenizing temperature. So once it is heated to austenizing temperature, so immediately cooling is done. So material gets hardened. So up to certain depth, so the hardening is done. So immediately quenching is done. So both the flame holder and the water tube moves in the same direction. A very slow movement will be there, so that complete heating has to be done and temperature should be uniform. So what was the temperature at this end? Same should be temperature at every point on the surface of the material. Now as it moves, so immediately quenching is done, material gets hardened. Once again remember, so entire workpiece is not it is hardened, only up to certain depth. That is how this flame hardening is done. So we use a gas flame and water as a quenching medium, so once it is heated, immediate cooling, so material surface of the material up to certain depth gets hardened. That is about the first type of surface hardening, that is flame hardening. Next we will move to the next type, that is induction hardening. So induction hardening. So induction hardening is once again a surface hardening process where we use a magnetic field generated by the induction coil. Magnetic field generated by the induction coil, so due to which the material gets heated, Now the setup used, you can observe this figure, this is the setup that is used. So this is the workpiece that has to be hardened. So here workpiece is placed here, above we got a inductor, below we got inductor. So above inductor, below we will be having inductor. So this is the inductor. So inductor will have small openings, so that is through which water will be circulated. So principle is that heating, immediate cooling. Principle of surface hardening is heating and immediate cooling. So these are nothing but the water tubes. So that we will be having holes drilled in the inductor, so through which water will be sprayed to the surface of the workpiece. So this is the bottom inductor, this is the top inductor. So then you can see the arrow mark, so water is entering in, and here both the inductors are connected to a capacitor and then in turn connected to a high frequency current. That is the entire setup that is used. So inductor, bottom inductor and top inductor, it is connected to capacitor to store the energy, and we got high frequency current. So that is the entire circuit or setup that is used in case of induction hardening. Then coming to the working, once again it is a very simple process, So here the workpiece is placed in between, so you can observe workpiece is placed in between the that is inductor, bottom inductor and top inductor. So it is connected to the high frequency current. When the circuit is on, so current is generated, so the current passes through the inductor in this direction, similarly in this direction, and an induction coil or inductor will have induction coils through which current passes, and here when induction coil passes, magnetic field is generated. So this magnetic field, it tries to it occupies the surface like this, and it will be touching the surface. This surface gets heated. So when magnetic field starting induced into the workpiece, so workpiece opposes for the flow of current. So workpiece opposes the flow of current, due to which heat is generated. So continuous magnetic field will be generated, continuously magnetic field will be generated, and continuously the workpiece will be objecting the flow of magnetic field through it. So when it objects the flow of current through its medium, so heat is generated, due to which the metal surface gets heated. You can observe this is the region that is getting heated, this is the region here it is getting heated. So immediately, so water will be continuously circulated. So water enters through this and it gets sprayed over the heated surface. So water gets sprayed over the heated surface in this direction, similarly in this direction. So immediate cooling is done. Immediate cooling or immediate quenching is done. Once immediate quenching is done, so the surface gets hardened. So once up to required depth, so once again here, so you can see this is the portion that is not heated. So this is the portion that is not heated, this is the portion not heated. So only this is the portion where heating is done. So this is the region where the hardness is increased. So in turn surface hardening is carried out by this method, is called as induction hardening. That is called as induction hardening. So these are the two methods of, that is surface hardening. First one flame hardening, second one is induction hardening. Coming to the advantages, what we can look with this induction hardening is that heating process will be fast. Compared with the flame hardening, heating process will be fast, and you can get a very good finish. So this was one of the objective of surface hardening or surface heat treatment. So what was discussed in the previous session. So a very good surface finish can be achieved. Second one, heating process is faster when compared to flame hardening. Heating process is faster when compared to flame hardening. So that's about the second type of surface heat treatment, that is called as induction hardening. Next, once we know, we discussed about surface hardening process. So two types, induction hardening and flame hardening. One more concept what we will be discussing is called as edge hardening. Edge hardening. So name itself tells that edge hardening. It is also called as precipitation hardening. Edge hardening is also called as precipitation hardening. So what is this edge hardening? So we have discussed different methods where hardness can be increased. So one of the heat treatment process where hardening. So hardening, so that is what we have discussed. So here surface hardening. So whether it's case hardening or surface hardening, once again hardness is increased. So here in all the cases, by some mechanism or by some principle, the hardness is increased. Now here we have got one more what we can call as a special type of hardening process, that is called as edge hardening. So what is edge hardening? So some materials or some alloys like aluminum zinc, aluminum copper, then copper tin. So these are the few of the alloys. So these alloys, when it is kept at a constant low temperature for a long period of time, its hardness is increased. So this is not seen in all cases, remember. It is observed only in certain type of alloys like aluminum zinc, aluminum copper, then copper tin. So these are the few of the alloys where we can observe this change. So when it is kept at a lower temperature for a longer duration of time, so its hardness gets increased. So that is nothing but passage of time or passage of age. That's why it's called edge hardening. That's why the name is given as edge hardening. So when it is kept at that lower temperature for a longer period of time, its hardness increased. Its hardness gets increased. That is why it is called as edge hardening. So one more name it is given as precipitation hardening. So edge hardening is also called as precipitation hardening. So one more principle is that when same alloys like copper, tin, copper, it is where we have seen this type of process taking place in the same alloys. So when it is heated to a certain temperature, so a very low temperature, so when it is heated to a certain low temperature, so at that temperature we can observe that hardness is increased. At that temperature, when it is maintained at that temperature, its hardness is increased. So that's why it is also called as precipitation hardening. What is precipitates? So suppose if you take salt, you apply salt is dissolved in water. So the amount of salt that remains undissolved, that is nothing but precipitates. So we come across this in chemical solutions. So when some amount of salt that is left undissolved, so then that solution is called as precipitate solution. So that is what we see in case of edge hardening. Hence it is also called as edge hardening process. Now once we know what is edge hardening or precipitation hardening, how the process is done in case of edge hardening, or how hardness gets increased by this method of edge hardening. So here hardness of the material gets increased in 3 stages, or the process is carried out in 3 stages. The first one is solution treatment, second one is quenching, third one is aging. So solution treatment, then the second one is quenching, and third one is aging. So here same example, if you take copper tin, or your example if you take as a copper tin, where when you heat, first stage is solution treatment. So copper percentage will be 4%. So percentage of copper will be less. So when it is heated, so it is brought to solution state. So it is heated to a certain temperature. It is heated to a certain temperature. So where it is converted into solution form. Where it is converted into solution form. Hence it is called as solution heat treatment. Solution treatment. So here initially if you plot a graph taking temperature versus this is temperature, this is time. Initially it will be heated to a certain temperature. So you will be having a structure, where you will be having small granules like structure that is seen. So this is the first stage. So first stage, that is solution treatment, where a copper percentage will be less. So it is heated. So when it is heated, so this is the first stage, heating. So structure will be like this with small patches like seen over the structure. That is the first stage. Second one is quenching. So quenching is one where once it is heated to a certain temperature of say 560 degrees centigrade, around 560 degrees centigrade, then quenching, as already you know that quenching is cooling process. Quenching is cooling process. So when it's quenching in the second stage, so temperature is brought down. So temperature is brought down. So here you can see that temperature, it was high, it is brought down to a temperature. These small patches that are seen, so that gets dissolved, precipitated, that is quenching. So it gets dissolved, so in the solution. Next, once it is kept at this stage, or in some cases it is once again it is heated, temperature is raised to a certain extent, where so after it is kept at this temperature, or where it is rise to a certain temperature and it is kept at that temperature for a longer period of time, or the time period passes. So the age, that's what is called as aging. So you can see this, you can get a structure like this, where you will be having the precipitates present on the surface. So this is precipitates that are present, that is undissolved copper it is present, so that at different locations on the structure, that increases the hardness of the material. That is what we call as age hardening or precipitation hardening. It is carried out in 3 stages. So first one is solution treatment, second one is quenching, and third one is aging. So you can observe this graph, time on x-axis, temperature on y-axis. So initially the structure will be like this. So then it comes to this structure, that is second stage, and third stage. So it may be at the same temperature, or it may be rise to a very low temperature and kept at that temperature for a longer duration of time. So longer duration of time, this is very much important. Age hardening. So age hardening, it takes a lot time. So when it's kept at that temperature for a very long period, its hardness increases. That's about the age hardening. So here we will continue with one more topic about ferrous metals. Now if we take metals are classified into 2 types. So basically ferrous metals and non-ferrous metals. What are ferrous metals? Ferrous metals are iron based metals. Majority of cases, applications, we go for iron based metals. Non-ferrous metals are which does not contain iron. So iron based, non-iron based, that is called as ferrous and non-ferrous metals. So here we will be discussing ferrous metals. In that we will be discussing 2 types of ferrous metals: cast iron, types of cast iron, steel, types of steel. Under each category we will be discussing its properties, then applications, and the composition. So what is composition? Composition is nothing but what it is made up of. So that chemical makeup is called as composition. What is property? Property is nothing but how the metal behaves under various conditions. That is properties. Applications, third one, where this particular type of metal is used. So three different category, three different thing what we discussed is, first one composition, second one the structure, and third one is its applications where we use this particular type of metals. So coming to the first one, that is cast iron. So entire thing is explained to this table. Entire thing is explained through this table. So you can observe that. So we got the first one is the cast iron. So we got material, first column, second one composition, third one properties, and fourth one is application. So in cast iron, basically we have got two types. So what we discuss according to the syllabus, so we will be discussing only two types, that is grey cast iron and malleable cast iron. So cast iron we got two types, so grey cast iron and malleable cast iron. So coming to the first one, composition, what is grey cast iron made up of? So it contains 2.45 to 4% of carbon, then 1 to 3% of silicon plus iron. So it is basically an iron metal. Iron, so cast iron it is nothing but iron based metal. So iron composition will be more. Iron composition will be more. Along with iron, we will be having carbon and silicon present. Percentage, so 2.5 to 4% and 1 to 3% of silicon. So remaining almost 90%, around 90% will be iron. That is the composition of grey cast iron. Then coming to its properties, it has got high fluidity. So what is fluidity? So fluidity is nothing but easily flowable. Means here iron is in solid metal, how it flows, the question arises. So fluidity is nothing but it is soft in nature, we can change into any required shape. So when it is heated, so casting, so cast iron is, basically in case of casting process, metal will be heated and poured into the cavity. So when it is poured into the cavity, it should easily flow and fill the cavity. So if it has got high fluidity, it fills uniformly the cavity. That is the first property, it has got high fluidity, means it easily flows in liquid state. Second one, high compressive strength. So we discussed properties, various properties in the second model. Compressive property, so or the strength the material that has got when it is subjected to compression, that is called as compression strength. And one more is low cost, it is low cost. That is the property of grey cast iron. Come to the applications. In almost all the cases, if you look at the applications, so most of the cases it is used in automobile industry, most of the components of automobile industry. So first one is pressure vessel. So pressure vessel, that is used in case of big boilers. So that is pressure vessel. Cylinder head. So cylinder is used in case of automobiles. So 4-cylinder, 6-cylinder, 8-cylinder like. So cylinder will have a head at the top which opens and closes according to the movement. So that head is made up of, once again, grey cast iron. Then piston, clutch plates. So piston is one more component, that is automobile that will be moving inside the cylinder, and clutch which engages and disengages, clutch plates, that is the application. Similarly, malleable iron, so once again it is made up of carbon, silicon, but percentage varies 1.8 to 3%, 0.3 to 1.8%, remaining is iron. Then it has got property highly malleable. So what is malleability we have discussed in the second module in properties. So highly malleable, good machinability. Good machinability means when it is the material subjected to various machining process, so it easily responds. If it is not, then the specimen breaks. So that is good machinability. Low resistance. So that is the properties. Then applications, connecting rods, once again a vehicle components. Then transmission gears. So gears are used for transmission of motion. So transmission gears, only particularly transmission gears, this malleable iron is used. And valves. So valves, once again in case of cylinder, that is in case of vehicles. That is about the cast iron. Coming to the steel. So steel, we have got three types: low carbon steel, medium carbon steel and high carbon steel, based on the percentage of carbon. So based on the percentage of carbon, low carbon, then medium carbon and high carbon. So low carbon up to 0.25% carbon, medium 0.25 to 0.5, high carbon 0.5 to 2% of carbon. So based on the carbon content, low carbon, medium carbon and high carbon. So coming to the properties, low carbon. So whenever the carbon content is less, material will be soft in nature. So that is one property. Ductile. So what is ductility? Ductility is a property where the material can be drawn into thin wires. So only if it is soft it can be drawn into thin wires. That is ductile. It has got high toughness and good machinability. So same machinability. So here low carbon steel has got good machinability. Then come to the applications, automobile body building. Any vehicle if you take, so body building, particularly if you take four-wheelers, so outer body, so that body is made up of this low carbon steel. Then building structures, then cans, structures. So in case of civil works, so building we use steel, that is medium carbon steel. So that is building structures. Then high carbon steel, so it is 0.5 to 2.1%. So when the carbon content increases, so hardness increases, hence it is harder, stronger and low ductile. So once hardness is increased, it becomes strong, whereas it becomes more and more harder, more and more brittle. It becomes on the other end, as you increase the hardness, material becomes brittle and brittle. So once it becomes brittle, so it is not soft in nature. So means it has got low ductile property. Then coming to the applications, razors, knives, then hacksaw blades. So hacksaw blades that is used for cutting. So that is one more application where we use high carbon steel. So one more is medium carbon steel. So 0.25 to 0.5%. It has got less toughness and it is stronger compared to it is low carbon steel. Application, railway wheels. So all of you know about railway wheels. Then railway tracks. So tracks on which the rail will be running, coaches will be running. So tracks that is made up of medium carbon steel, and crankshaft is one more component where we use is medium carbon steel. So these are about the ferrous metals. So cast iron, types of cast iron.